Welcome to Understanding JavaScript crash course. Alright, the goal of this course: when JavaScript was created, one of its desired features was to be less error prone. As a result, this led to one of the most influential programming languages leaving a bad impression amongst new application programmers. This course aims to help you better understand these confusing aspects in JavaScript. Without wasting any time, let's get into the content. Environment setup. Here are the following things you're going to need in order for you to follow along with this course: Visual Studio Code, Chrome browser, internet access, and in your Windows operating system you need to enable developer mode. This will allow you to install applications from any source without Windows preventing you. Let's talk about primitive types. Now, a primitive type is a data type that represents a single value. These are fundamental building blocks for storing data in JavaScript. So JavaScript currently has 7 primitive types, which are as follows. First one being a string. String represents textual data, can be enclosed in single quote, double quote. Sometimes you can use backticks. Second one, we have numbers. This primitive data type represents numerical values including whole numbers, which are integers, floating point numbers, which are decimals. Third one we have is undefined. Now, undefined represents a lack of existence. This primitive type is mostly automatically used by the engine to be set as a default for any variable that you create. You can see here in this code snippet we have a variable named password. Contains nothing, but when you console.log it, it shows you undefined. So that means undefined has been set as a default value for the variable password. Undefined is not an error in JavaScript. The fourth one we have is Boolean. Boolean represents logical values. This can either be true or false. And the fifth one we have is null. Now, if you want to have an intentional representation of absence, you can use null in JavaScript instead of using undefined. You can see the variable is offline, it's initially set to null, and when you console.log it, it will show you null. The fifth one the sixth one we have symbols. Now, symbols is a unique and immutable primitive type. You can use it as a key of an object property. This primitive type is mostly used to create unique keys and guarantee that these keys do not clash with other keys from any code. You can see in this code snippet we have At the top we have value A, value 1 and value 2. Both have symbols with the string hello, but when you compare value 1 and value 2, the output will be false. They are not equal. Each of those values has a unique symbol. Now we have the object person, and we have the symbol ID that can be used as a key. If you want to get access to the value of the property ID, that number 123 can only be accessed by using this key ID. And then the last one, the seventh one we have, is big int. This one, if you want to use JavaScript to calculate large numbers and get precisions, you can use a big int instead of the number data type. Operators, what are they? An operator is a special function that is syntactically written different, typically takes two parameters and returns one result. So in other languages, operators, sometimes they are called keywords. Operators are functions that come pre-built with any programming language that you choose, and they allow you to write in prefix, infix, and postfix. Let's look at a PDF of these operators that are included in JavaScript. Okay, this is a PDF of operators currently included in JavaScript. Now let's start at the top. Let's look at under the header operator. Alright, we have this operator, and it is, the description of it is called expression grouping. You would use it like this. These are open brackets, and you would write the expression inside and you would group it. Alright, the second one is this dot. This is called a member of. You would normally use this operator to check a member of an object. Say you want to check the value of an object, you would type the name of the object and dot then the keyword of them, or the name of the member. This one also is a member of. This is not an array, it's a member of. You also use it in objects. Type the name of the object. Here the object name is person. You want to check the member, would be the keyword name, and it would return whatever value name has in this object person. And we have this one, optional chaining. This is a fairly new operator. Let's say you have an object X and you don't know if X has Y inside. So you would say if X you have Y, then you would check if you have Y. If you have Y, X would return true. So you will say if you have Y, give me Y. And then we have a functional. call. This operator is used to call a function, to invoke a function. And you have the new operator. Can use it like this to either create new object and as you can see in this example, they're using two operators. This new one to create a new object, and the function call to invoke the object, and passing parameter, which would be a string. And also in this example here, they're also using a new object without arguments, and they invoking this could be a class, or it could be a function without any arguments being passed in. And we have increment operators. Remember I said operators will allow you to write in postfix. This operator here is used as a postfix, so you would put your variable and your operator last, and this operator would return something and put it inside this variable. This one, this minus minus, is also used as postfix. It would take the value I and decrease it, and then return the results back into I. The prefixed one, you put the variable last and the operators first. And we have not operators. Now not operators basically negate whatever you give them. If x is equals to y, the not operator would basically say false. If this answer is true, you would say false. If it's false, you'd say true. And then we have unary operators. We have arithmetic operators. And we have shift operators. And we have rational operators. And then we have comparison operators. These are your greater than, your less than, your equals to, your less than, equals to, greater than, equals to, not equals to operators. And you have your bitwise operators, and you have your logical operators, and you have your conditional operators, ternary operators. Now this is not a function. Some people say this is a ternary function. No, this is a ternary operator, a conditional operator. Sometimes this operator takes 3 values. The condition would be first, followed by question mark. If the condition is true, then yes would be invoked. If it's false, then no would be invoked. And then we have assignment operators. This where you would assign y, the content of y, to a variable x, and we have a colon operator. As you can see, colon operators can be used in this Conditional operators, sometimes we mostly use them in objects. Colon operators. We have the plus equals, the minus is subtraction assignment. This one is the addition assignment. We have the multiplication assignment and so on. As you can see, JavaScript has a lot of operators. You also have the arrow operator. So here you would take y and do something, and then this arrow would return something from x, and you would hold it wherever you're holding it. This operator is mostly used in what you call an arrow function. And we have the yield. Now the yield operator is mostly used in a generator function, which we will discuss as we go along in this course. And then we have the spread operator. This operator is mostly used with arrays. And we have the comma operator. We'll talk about these operators a bit more as we go further in the course. Okay, typing system in programming. Now, typing system plays a crucial role in how we write and reason about code in a programming language. We have two types of typing system, dynamic typing and static typing. So JavaScript uses dynamic typing. In dynamic typing, you don't tell the engine what data type a variable should hold. The engine figures it out in runtime. A variable can hold different type of values. Now let's look at this code example. We have the variable pin. We initially assigned it to a number. When you console.log it, it would show you the number, and then we reassign the variable p to a boolean true. It would not give you an error. When you console.log it, it would show you true, and then again we reassign the variable pin for the third time with a string. When you console.log it, it should give you the string without throwing any error. This is what dynamic typing system looks like. Now let's look at static typing. In static typing, you need to tell the engine ahead of time what type of variable, what type of data does the variable hold. Let's look at this example of a Go programming language. This language is also a statically typed language. Now let's look at line 8. As you can see, we creating a variable pin, and in front of it we wrote int. That simply means this variable named pin will hold a decimal number, an integer. But here we assigned a string 31314. It should give you an error when you console.log it. As you can see, the error would say cannot use string untyped string constant as int value. JavaScript you won't come across such problems. Coercion, what is it? Now, in context of programming, this simply means converting a value of one data type to another. But in JavaScript, coercion refers to the automatic or implicit type conversion that happens when you perform certain operations involving different data types. So when you're using different data types in JavaScript and you're performing some actions with certain operators, implicit coercion may occur. Let's look at the examples for comparison operators with coercion. Now this code example of the equality operator. When you're using the equality operator to compare a number data type with a string, the results of the equality operator would return true because coercion has occurred here. The JavaScript language, when it was created, one of the features was it to be less error prone. So coercion came about, as you can see, as a implicit coercion came about as a side effect. Now, how do you get true when you're comparing two different data types with this equality operator? Well, the string is coerced, is implicitly converted into a digit that would be a number type, and then those two number types, 0 equals to 0, they would give you true. Now on the second one, we have a number type of a value 1 being equated to the boolean type true. This also would give you true because true is also implicitly converted to a number that would be 1, and the end result would give you true. Let's look at inequality operator. The inequality operator, as you can see, we have said that string 1 is not equal to the number 1. This would give you false. It should have given you true, but implicit coercion has happened here. So the string was coerced into 1 and then compared to 1. So it was coerced from a string to a number type, and then two number types were determined using the inequality operator, and it said false because the number digit 1 is equals to 1. Now in the third example, we have 0 is not equals to false. Again, these are two different data types, number and a boolean. So the reason for the end result being false is because the false was implicitly converted to a number type, which is 0, giving you false. When you compare two number type values being 0 and 0, they are equal. So when you say 0 is not equal to 0, you would get false. Now we have exponents. Now exponents, this example is mostly about operator precedence, which we'll talk about later. Okay, now we have this. So let's look at this other example where a data type 1 number is added with a string containing the number 1, and it's being equated to the number 11. Now the end result of this expression would be true. How did it come about? Well, first, the addition operator here, adding number 1 with the string 1, would act as a concatenation operator. So it would first convert that data type number 1 into a string, add it to this other string of 1, and it would be a string of number 11. And that we move to the next step, where a string of number 11 would be equated to the number type 11. Now this string would then be converted into a number type, and then we'd get 11 is equals to 11, and that would be true. Let me show you this example with some code. That example was like this. Now the first step the engine does is it would take this number type data type 1 and not add it, but concat the string with the digit, converting it to string number 11. Now the second step where we equate this string type 11 to the number data type, would say 11 is equals to this. Now this operator would say you have given me two different data types, so it would implicitly convert this string 11 into a number data type and then compare it with this other number data type and then return true. Now this should make sense, because when you explicitly convert a string 11, it will give you the number type value being 11. So that operator underneath does something like this. It would say you've given me two different data types, a string containing some characters and a data number type, which is integer 11. You would convert the string into a number and it would equate it and say true. The classic 0 is equals to an empty array expression. Now in JavaScript, majority of the time when you talk about coercion, or when you're learning about coercion, you're going to come across this example whereby a number type of a value 0 is being equated to an array. Now remember, in JavaScript, this array is not a primitive type, but it can be used to create an object which is known as an array. Can be used as a member of, to look for things in an object. Want to access an object properties. Now when you compare a number with an object, or an empty array in this instance, the object is converted to a primitive value before the comparison, so before the final answer is returned. So this empty array would be converted to, would be coerced to 0, and then that 0 would be compared to the initial number 0, and it would result in true because both sides are coerced to 0. Now let's see how this works. First, there's loose equality operator. Sees that you've given it two different types, a number and an object. And the second step this operator takes is it converts them, these two different values, to a common type before comparison. Then the third step, it would take this empty array, convert it to a number, being 0. Now compare 0 is equals to 0, and you'd say true. Now let's look at this with some code. So this statement 0 is equals to empty array. It's true. Now how does this step happens? Inside this equality operator, there is some, remember this is a special function, so there is some code written in this special function. When you give it two different data types, it would implicitly convert all of those data types into the same data type. So it says you're giving me 0, which is a number data type, and you're giving me an object. An object is not a primitive data type, but I'll explain it a bit in the upcoming lessons. So for this example, an object, it will just say it's one of the primitive data types, but it's not the same to the number. So inside this equality operator, it would do something like this. It would convert the array to a number and get 0, and it would take that 0 and go and see if do I have two exact same data types, and if it's yes, it would compare those data types. So you take that initial 0 that you gave it with the array and replace that array with the 0 that it has, and you say true. So hence 0 is equals to empty array. And this would give you a different result if the array had something in it. It'd say false, because it would also try to convert this array into a number. It would get something like this, not a number. So as you can see, it would do something like this. That's how you got this false. Most of these operator functions, they compare data types, or should I say values of the same data type. So if you're using the addition here and you're adding to a number in a string, one of these arguments that you passed to this addition as an addition operator will be implicitly coerced until you have the same data type on both sides. As you can see, even here we're concatenating two strings. If it was a string and a number, one of those arguments passed to the operator would be coerced to either a string or a number. And it depends on how your code is written. Comparison sameness. In JavaScript, comparison sameness refers to comparing two values for equality. So there are three type of ways you can compare two values using a value comparison operator. You can use the equality operator, you can use the strictly equality operator, or you can use the object.is. Let's look at the PDF. Now this is a PDF explaining how these three operators work: the equality operator, strictly equality operator, and the object.is. Now let's say we have two variables, variable x and variable y. Now both variables, you use an example. Open up the console. Say we have variable x and variable I. We have not assigned anything, so the JavaScript machine automatically assigned us an undefined in both our variables. New console.log x and y, you'd get undefined. Now when you use the equality operator, you say x is equals to y, it's going to say true. When you use the strictly equality, that's 3, it still to say true. When you use the object.is, you put in x comma y and close, would give you true. The same is with when you have assigned null to variable x and y. You compare them using three of these operators, they would all give you true. The list goes on and on, and now there comes some different answers. When you assign +0 to variable x and -0 to variable y, When you use the equal sign, it would give you true. The strictly equality true, but the object.is would give you false. Now this is where implicit coercion starts to take place. When you assign -0 and 0, the equal operator and strict equal operator would give you true, but the object.is would give you false. As you can see, coercion is now starting to take place in your equal 0 number type with boolean false. The equal operator would give you true, the strictly equal would give you false, the object.is would give you false. As you can see now, with an empty string, comparing it to 0 using the equality is true, but with the strict equality set it's set false, and with object.is it's set false. Now the list goes on, an array with 2 values, 1 and 2, and an empty and a string with 1 and 2. Here, using the equality operator, it's being implicitly coerced, thus would give you true. Using the strict equality, it would give you false. Using object.is, it would give you false. Now this list goes on and on, but as you can see from most of these comparisons, object.is made more sense than the equality operator and the strict equality operator. So if you want to avoid implicit coercion in most instances, when you want to use the equality operator, the strict equality operator, rather use object.is. From that earlier example of ours where we got this 1 plus string is equals to 11. If you wrote this using the strict equality operator, you would get false. But if you just want to avoid the headache, you can just use an object.is where you could pass that number plus string and see if it's equals to 11, and it could give you false. So in instances where you want to compare two values and you want to use an equality operator, strict equality operator, rather just use object.is.